So everybody in here was given a box, and you were given some Unifix cubes, and it wasn't enough to fill up the entire box. You agree with that?
Yeah.
And there was no way to do that. And I asked you a simple question. I said, how many cubes do you need to fill up your entire box? And so we all came up with some ideas to figure out what that number might be. And we're going to get into whether we did the correct thing, if we did part of the correct thing, if we were doing the completely wrong thing. We'll figure that out in a few minutes. I did see some really amazing thinking as we were going around. But I'm going to start off with this rectangle. And if you were given the problem of this, let's just assume that these squares are 1 inch apiece.
Okay.
Good?
Yeah.
Everybody good with that? And I only gave you this many squares. But I said to Lily, Lily, can you help me find the perimeter of this? Number one, you would need to know what perimeter is, right? What is perimeter? The outside. So I feel like you and I could take this over here and figure out how many squares it takes to fill up over here. Would you agree with that? Okay. So how many squares does it take, Lily? 6, 7. Now, if they're worth an inch apiece, what is the length of this side? 7 inches. Now, because of what we know about rectangles, do I really need to move those to the other side? No, the opposite side is how many inches? 7, because they have 2 equal sides, right? Could I figure out what one of these other sides is? Well, sure. I could put these together here. Can I take it from here? Sure, because I already know what that side is. I may have enough, I may not have enough. I don't know. We'll see. I think I should. I think I copied enough. If not, guess what? I can copy more of these. I did put not enough to fill the whole box up, but too many squares to just, fill up one side, kind of like we have here. And let's get these out of the way because I'm going to have too many. And I know that I put some not far enough apart. So how many is over here? So you can move along with this. So 1, 2, 3, 4, 5, 6, 7, 10, 13, 14, 15. So now I saw using these squares that this is 15, and what you just told me, I know that this side is 15. So we were able to determine the area, the perimeter of this figure by doing the outside, correct? So if we figured that up, 15 plus 15 is 30, 7 plus 7 is 14, 30 plus 14 is
44.
So the perimeter equals 44. Now, same shape. Could I figure out the area? I think I could because you know the definition of area because I've heard you say it before. Someone raised their hand. Tell me the definition of area.
Inside.
What inside? The what and the what?
Like what's inside? Like the boxes.
How many boxes can I fit inside of there? But there's a formula for that. Now I don't have enough boxes for you and I to put them in here. Now listen, I already know that there's going to be how many on the inside here? 7, right?
Yeah.
I don't have enough boxes to fill this entire thing up as I go through and put my 7 boxes on the inside. And I know that how many go across the top? There's going to be 15. And all of a sudden, when I start doing this, I'm out of boxes. I can't fill up the entire thing to give you the area because I don't have enough boxes. This is very similar to the issue you just faced with the boxes because you had 3-dimensional boxes, right? They have, whoa, that's not what I wanted. They have a length, a width, and a height on them, right? This one just has a length and a width. I don't know how tall this is. So good. 15 on the inside. So now what formula could I use, sailors, to tell me how many of those little boxes would fit on the inside?
15 times 7.
Length times width. Because I know that area, length times width. And so I would need 15 times 7. So I get an area of 105. Now, boys and girls, this is a flat two-dimensional box. You had a box with 3 dimensions. Can you see that? Do you see that your box has a length? Some of you measured the length and you went all the way down the side of your box and you got some different numbers, didn't you? Does your box have a width? I'm looking inside of theirs. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It has a width, but it also has a what? No. Height. Is there a secret formula for me to figure out the volume of a shape? Is there a formula for me to figure out the volume of a shape? So let's take a look at this. Do you have a width to your box?
Yes.
Does this look remotely like your box if you divided the box into a little bit into cubes? Yes. For the most part, yes. Do you have a width?
Yes.
Yeah. Do you have a length?
Yes.
And you also have a height? Yes? How can I figure out how many cubes are inside in total? If I have a length, I have a width, and I have a height. You have, listen, you have so many. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That 12 has to come all the way this way. Is that how many there is? There's 12 of those. So that would be 84. But that's only one row. I need that to go up how many times? Because I don't know what the height of your box is, right? So I have length, I have width, and I have height. Check this out, Lily. You're going to like this. Length times width times height is our volume. So if I take a look at this and I say that, what is the length of my box? Stop. What is the length of my box? 4. What is the, should be this color, there we go, width of my box? And then I have to ask you, what is the height of the box? 1, 2, 3, 4, 5. 4 times 3 times 5. Now we just got done doing PEMDAS. I have to do it in order, correct? 4 times 3 is? 12 times 5 is?
16.
So here's where some people might get confused on this. If I were to try and actually count, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. I'm missing some, right? Can you actually see that middle row from here? Can't see it. That's the hardest part of volume, is looking at things that you can't see, but you know they're there, right? I know that there's cubes in there. If we filled your box up, we know that there would be cubes in the entire box. Can you see all the cubes? You can't see any on the bottom. You can't, unless you take the whole thing out, right? So now, I'm going to pause my video here. I want us to go back and measure the length, the width, and the height of that using our length times width times height formula to tell me what the volume of your box truly is in Unifix cubes. So again, I caution everybody, Carson, that's enough, sir. I caution everybody that this starts off very simple. It really wants you to understand the basics of finding the volume. Eventually, they're going to start having you find the volume of something, and they're not going to give you the little cubes in there. They're just going to give you numbers. Then they're going to change it also from that, where it's a regular shaped thing, to where there's like chunks of it that are taken out, and then you have to start breaking it into pieces and doing some subtraction and some addition, which makes it even harder to do. So don't let this fool you into thinking that this is super easy and just stop paying attention. Enjoy the ease that we have now, knowing that this is going to get more and more difficult. We're just trying to build a very solid base that will hold you up when we get to the more difficult pieces. Cool? All right. Again, we have the formula. It's got it up there for us because at some point, just like area, they're not going to let you have that anymore. They're going to need you to memorize that volume is length times width times height. Now, if I look at this in particular, and I'm going to, is it still frozen? No. Unfrozen? No, still not. Still frozen. What in the world? There we go. All right. If I'm going to look at the length of this shape, my length is what, Sam?
2.
2. Pretty easy, right? Not too hard. Then, Sam, if I look at my width, what do we have?
2.
Still 2. Still not tough. And then, sir, last but not least, I'm looking at my height. We have
5.
1, 2, 3, 4, 5. I agree with that. And 2 times 2 is?
4.
And 4 times 5 is?
20.
So this has a volume of?
20.
Trying to look over top of your shoulders there. It is a volume of 20. Is that an overly difficult problem? I don't believe so. Again, we're not working ahead. I know that it's very tempting to be like, I've got this. You don't. I promise. It gets so much harder after this. So much harder. Izzy, number 2. Okay, I look at this shape. It's a little bit different than the last one, but I can still find the 3 measurements that I need. What is the length of this one?
4.
Okay, 4. What is the... Oh, that's not what I wanted. Different colored highlighter there.
That's the same color.
There we go. What is the width?
5.
5. And then last but not least, young lady, what is my height?
3.
Length times width times height. 4 times 5
Is 12.
and 20 times 3.
60.
I am going to let you do the next one on your own, and we're going to see if there are any misconceptions going on in the classroom. All right, Ronak, we've had some time to take a look at this as individually, so let's take a look at this as a class. My length on this one is, sir?
3.
Oh, that's not good, but we'll just leave it there because I think I can still see it. My width, sir, is?
Your width is 3.
And then my height?
The height is also 3.
The height is also 3. And 3 times 3, sir, is?
3 times 3 is 9.
9 times 3 is?
27.
So this has a volume of 27. So far, so good, right?
Yeah.
So, Austin, when we take the test, I know I've said this before, and I'll say it again, and I'll say it for a while. You can't miss the easy ones on tests and quizzes, right?
Yep.
When you have one that looks like this, you just can't miss it because the irregular ones are going to be the ones that give us the most trouble. I'll give you a brief overview of your homework for this evening. You're going to see some things that you've done before, and you're going to see some stuff that we did today. Number 1, I think it's pretty easy. Measuring cubes. I think that's an easy one to figure that out. This is exactly what we did in class today, correct?
Yeah.
Should not be a problem. This is a little different. This is what we actually did physically in class, isn't it? We had a box. We had the measurements. We figured it out.